No cheat from yesterday.
You're asking what calculator?
7.31.
Alright, here. These strawberry ones? Can I have one?
All right, guys, so this is where we left off yesterday. So, at this point here, we're going to find the product. All right, guys. We're going to find the product of these two rational expressions, and we're multiplying by polynomials. We have multi-terms. Because what we finished up yesterday was multiplying by monomial terms on top and bottom one term, like 3x. Now, whenever we do this, we do need to make sure that all of our expressions, top and bottom, are written in standard form. Because if we look at the top of this first one here, it is not, because we have 3x minus 3x squared. So it'll be helpful to have these written in standard form first, which means we're taking the minus 3x squared, moving it to the front, and we put our positive 3x after it. Because having it written in standard form will help us be able to factor it a little bit easier. Questions on this so far? Now, whenever we do have single terms like 3x, they're actually as simplified as they get. So if we have a single term, such as 3x, we can't do anything with it. But our other two, our x squared plus 4x minus 5, two sets of parentheses, factor it, and our x squared plus x minus 20. Now, out of these two here, we need to determine which one we want to factor first.
X squared. X plus x minus 20.
So we'll factor the numerator of our second term, our x squared plus x minus 20. Since our third term is negative, our signs are opposite. We have plus and minus. Now we need to look at the factors of x squared, which would be x and x. Now our factors of 20, there are a few. 1 and 20, 2 and 10, 4 and 5. Guys, let's focus in here. So we have 5 and 4. So we have x plus 5 times x minus 4. Now we can check to make sure that this does work. So our x times negative 4 would be negative 4x. Our 5 times x would be plus 5x. And our negative 4x plus 5x would be a positive 1x, which is indeed the middle term we wanted. Now we can factor our other set of parentheses, our x squared plus 4x minus 5. Since the third term is negative, our signs are opposite, plus and minus. Now the factors of 5 are 1 and 5. Do we want to put the 5 with the plus or the minus? And then our factors of x squared are x and x. Because if we put the 5 with the plus, x plus 5 will now match on top and bottom. It will reduce. Otherwise, we wouldn't have anything in common. Now we can check to make sure this does work. X times negative 1 is negative x. 5 times x is plus 5x. And negative x plus 5x is positive 4x, which is indeed the middle term we wanted. So, those two factored. We're almost to the part where we can multiply, because there is still one other thing we can factor. Our 3x squared, negative 3x squared plus 3x. We didn't factor it in this first step. All we did was rewrite it. Now, we don't have a constant term, so it's kind of difficult to do.
William Hamilton, please come to the office. William Hamilton.
Our two sets of parentheses. But is there a greatest common factor between our negative 3x squared and 3x? Yes, we do have a 3 and we do have an x. Now, one thing to be paying attention to, whenever the exponent with the biggest, or the variable with the biggest exponent is negative, we want to take the negative with it. We want to try to keep that variable, that first variable, positive. So since it is negative 3x squared, this time we're going to factor out a negative 3x. If it had been positive 3x squared and 3x, then we would have just taken the 3x out. Because by taking the negative 3x out of negative 3x squared, the negative 3 simplifies out. The x squared becomes x, positive x. Our 3x would factor out completely, giving us 1. But since we factor the negative out, it's going to change it from positive 1 to negative 1. And we have this here. Questions on this here before we multiply? Okay. So we're going to multiply these together, yes? Well, you don't have to write this piece in blue. But our x plus 5 and x minus 4, what operation are we doing between those two? We're timesing them, we're multiplying them together, right? So if we have two sets of parentheses, we can put them next to each other, and it's understood to be multiplication, yes? So if we're multiplying the entire numerator, and we have these different sets of parentheses, well, we'd have our 3x times our x minus 1. What can we do with the x plus 5? We can just put it right next to it, and the x minus 4, because that should be plus. Because we multiply those two numbers together, because of the parentheses, we just put them next to each other, and it's understood that they're being multiplied together. Same thing is true with our denominator, but it is helpful, especially with simplifying and keeping terms, keeping track of all of our terms, to move any monomial or single term expressions, in this case the 3x, to the front, just so we can keep track of them, keep them all in the same place. Questions on this here before we start simplifying? So what's in common on top and bottom? X minus 1 and x minus 1. Anything else? X plus 5 and x plus 5. And lastly, 3x and 3x. So in the numerator, what we're left with is negative x minus 4. What's left in the denominator? Nothing. So it's reduced to 1. So, because where is it 1? It's 1 in the denominator, yes? Well, division of 1 doesn't really do anything, because 6 over 1 is the same as just 6, yes? So here we don't even need the division of 1. Our answer is just negative parentheses x minus 4, close parentheses. If the x minus 4 had been at the bottom of the fraction, then we'd have the 1 over. So we don't have to put the 1 on bottom, but we do need to put it on top. Questions on this here? You ready for another one just like it? Find the product of these here. And again, just like the last one, we have 5x minus 5x squared. They have those two flips. We're going to need to flip them back, yes? Well, there's nothing that states that we have to rewrite that in the first step, because we know negative 5x squared plus 5x, yes? I can write it over the top of it, just so we have it, or we can see it. And then as a reminder to myself, I can mark it out. And especially if you're doing these on the homework and they have it flipped like that, because normally we copy the problem down to start. Well, might as well go on and flip those two as we're starting the problem, as we're copying that down. That way we're not having to completely rewrite it as part of one of our steps. Does that make sense? Well, out of the four of these here, which one is the easiest to factor first? Yeah, 5x squared.
Oh, wait. Are you talking about those two?
We could do those two. Personally, I think 5x.
Oh.
Yeah, you're good. Yeah, because 5x is just 5x.
So we were moving on.
That's crazy.
Yeah, but we can do the negative 5x squared plus 5x, because that is another easy one to factor. Because we don't have two sets of parentheses. There's just a greatest common factor of 5
X.
and x. And we do the negative. Because the first term, that x squared term, is negative, we have to take the negative out. So if we take negative 5x out of 5x squared, we're left with x. 5x out of 5x is 1. And then we have a minus. So we have negative 5x times x minus 1. Because the 5x factors out completely, and if something factors out completely, it reduces to 1. Now we need to factor the other two. I would start in the denominator, our x squared minus 4x plus 3, because we do have one of the factors in one of the two numerators, yes? X minus 1. So if we're lucky, hopefully one of these two in the denominator will be x minus 1. Because if it is, they'll simplify. So if we look at the factors of, or to factor 4x, let's try that one more time. If we look to factor x squared minus 4x plus 3, since the third term's positive, our signs are the same and match the sign of the middle term. Minus and minus. Factors. X and x, factors of 3 are 1 and 3.
Oh, I was talking about 4.
And if we do check this, x times negative 3 would be negative 3x. Negative 1 times x would be negative x, giving us, which is the middle term we wanted. So do we have something in common on top and bottom? Yeah. Because it's already in the same fraction, I want to simplify it. Because we can multiply it together and they would still simplify later. We can do it now, or we can do it later. Yes, and then simplifying it down. And again, that's why we went over factoring again, because really if we think of these here,
I can smell penny.
let's look at this one here, x squared minus 5x plus 6. Third term's positive, so the signs are the same and match the sign of the middle term, which would be negative and negative. Factors of x squared. Now the factors of 6, 1 and 6, 2 and 3. 2 and 3 would be more helpful, because with 2 and 3, we now have an x minus 3 on top, and that would cancel out. Now we can still check to make sure. X times negative 3 is negative 3x. Negative 2 times x is negative 2x, which does give us a middle term of negative 5x. Yes. Well, there's two ways we can do this. I'm going to show you one way. One, because again, what are we doing? We're just combining these into one, because that's all we're doing. Because when we rewrite it, we're just moving the numerators together, denominators together, yes? So I could just draw a line, connect the two, and our x minus 3 and x minus 3 would cancel. Our entire 5x would cancel out with 5x, leaving us with negative x minus 2. Well, and that's it. There are restrictions, but we're not going to worry about those here. Questions on this here? We're ready for the next one.
That's it right there.
Now there's two of these that are easier to factor into our next step than the other two.
Oh, we're on 6. Oh, shoot.
What's one of the nice ones to factor?
2x squared.
Yeah, 2x squared, because it is
2x squared.
2x squared. Since it's a single term, it's a monomial, there's no way to factor it other than just it is what it is. What's another one that's x plus 3? Because we have two terms, the degree is 1. We know the degree because it's the exponent. Biggest exponent attached to the variable, in this case, is 1. So we're looking for greatest common factor between x and 3. Is there one? No. So that remains x plus 3. We can put parentheses around it. We don't necessarily need it at this point, but when we do multiply them, we'll have to add the parentheses. Now we have 2x squared minus 10x and x squared minus 25. 2x squared minus 10x. We don't have a constant term, so it most likely means there's going to be a greatest common factor. What goes into 2x squared and 10x? 2. 2 and x. Now if we factor 2x out of 2x squared, we're left with x minus. If we factor 2 out of 10, we have 5.
What? Oh.
And the x factors out completely. Because really what we're doing when we factor something out is we're just dividing each term by what we're factoring out. So we're dividing the 2x squared by 2x. 2 divided by 2 is 1. X squared divided by x is x.
Wait, where did your brain get 8 at?
Because I thought we were subtracting 10. Or I thought we were subtracting 2%.
And then 10x divided by 2x, 10 divided by 2 is 5. Our x divided by x is 1. So we just have 5 times 1, or 5. So the last thing we have to factor is x squared minus 25. We have no middle term.
X minus 5 squared.
Since we don't have a middle term, x squared is x times x. 25 is 5 and 5, yes? So this is a difference of perfect squares. So we would have x and 5, but our signs would be
Oh, negative. Sorry.
opposite.
Oh, it's negative.
Third term is negative, but also our difference of perfect squares, a squared minus b squared, is a plus b times a minus b. In our case here, a is x and b is 5. Questions on this here? So we can put these together. And what simplifies? X minus 5.
That's 2x.
2x.
No, not 2x, because it's not squared.
No, it's 2x.
Oh, it's 2.
Oh,
It's 2.
The 2 and 2 will cancel out. But we have x over x squared, yes? X over x squared. Whenever we divide like bases, because x over x squared, they're both x, we subtract the exponents. So the exponent on top is x to the first. X squared's on bottom. 2 minus 1 is 1.
Well, what's the answer?
Since it's bigger on bottom, it stays on bottom.
Why am I putting that on?
Because if we think of the x's, because we have 1 x on top, we have 2 on bottom. So the 1 on top, 1 of them on bottom cancel out. We have 1 left over on bottom. Now what's left on the numerator, because that's gone, is our x plus 3. Because our x and x did simplify, and that also leaves us with x plus 5 on bottom. Because we still had an x plus 5 term. Questions on this here? Questions on anything we've done so far?
Like I said, it was a long order.
When you said 2 minus 1, I said
We ready for the next one?
Yes, sir.
C to the 8th,
God,
C to the 3rd plus 8, over C to the 5th minus 4C to the 3rd, times C to the 6th minus 4C to the 5th plus 4C to the 4th, over C squared minus 2C plus 4. C to the 3rd plus 8 over C to the 5th minus 4C to the 3rd, times C to the 6th minus 4C to the 5th plus 4C to the 4th, over C squared minus 2C plus 4. Now we can look at our C to the 6th minus 4C to the 5th plus 4C to the 4th. Is there a greatest common factor between these three terms?
C. C.
Oh, wait, which one are we talking about? C to 4.
Oh, I didn't know which one we were talking about.
All freaking knew it.
C to the 6th minus 4C to the 5th plus 4C to the 4th. There's a C to the 4th term in all three that we can remove. If we remove C to the 4th from C to the 6th, we're left with C squared minus. If we remove a C to the 4th from C to the 5th, we have a C, and we still have the 4, so 4C, plus,
Plus 4.
and we remove C to the 4th from 4C to the 4th, we're just left with 4. Now there is another one that does have a greatest common factor, and that's our C to the 5th minus 4C to the 3rd. What would the greatest common factor be? C cubed, C to the 3rd. If we remove C to the 3rd from C to the 5th, we have C squared minus 4, because this other C cubed factors out completely. Questions on this so far? So far, we've just done greatest common factor.
C3 plus 8 will just stay like that, right?
Yes, if it's not a sum of two cubes, because our sum of two cubes difference of two cubes. And the only reason we would think to look there is because of our C to the 3rd power. It's a cubic. And when we looked at cubics with the factoring, we took the cubed root of C to the 3rd, which is just C.
2.
And the cubed root of 8 is 2. So that tells us this is a sum of two cubes, and it is factorable. So we have our term with 3 spaces and our term with 5. Our signs are the same. Opposite. Always end on a positive note. Our first term in this case is C. For the bigger spot, we have C squared, C to the 1st, and no C term. In the other spot, we have 2. The middle, we have 2 to the 1st. And the last one, we have 2 squared. So we will need to simplify that. With everything going on that we've factored so far, let's leave the C squared minus 2C plus 4 for a minute. We'll get to it here in a second. Questions on this here before we move on to the next part? So in the numerator for our first one, we do need to simplify our C squared, the quantity C squared, which is just C squared, minus C times 2 is 2C, plus 2 squared is 4. A part of that statement does look familiar, yes? C squared minus 2C plus 4. we have it in the denominator on the other side, yes?
Yes, sir. Cancel that out, buddy.
So those will cancel out. So if, or whatever the factors of c squared minus 2c plus 4 are, they'll still factor with c squared minus 2c plus 4. It actually also works out that c squared minus 2c plus 4 does not factor. Because the quadratic, this part of the sum or difference of perfect cubes, is not factorable. Now we do have our other two parts. First one we have is c squared minus 4. This is a special type of quadratic. We call it what? A difference of perfect squares. We have subtraction. So the signs are opposite. What times itself is c squared? C and c. What times itself is 4? C minus 2 and c plus 2. C squared minus 4 is a difference of perfect squares. Because if we have two terms being subtracted, we need to check for perfect squares, because if it is, we just see what times itself is the first term, put it in the first spots. We see what times itself is the other term. We put it in the other two spots. Now the last thing we have to factor is our c squared minus 4c plus 4. Third term's positive, so signs are the same.
There's negative,
Both negative. Signs are the same and match the sign of the middle term, minus and minus. Factors of c squared, c and c. Now there's two factors for 4, 1 and 4, or 1 and 4, or 2 and 2. Which ones do we want to try first? 2 and 2, because if this does work, then we do have something that is in common on top and bottom. And if we check this here, c times negative 2 is negative 2c. Negative 2 times c is negative 2c, which does indeed give us our negative 4c middle term. And again, at this point, we can add the parentheses around that and connect these two together. Now at this point here, what simplifies out? Our c plus 2 and c plus 2. We also have, yes, we have c squared minus 2c plus 4. One of the c minus 2s. Now we also have, so we have c to the 4th and c to the 3rd, yes? C parentheses c minus 2. Now, a way that we can do this and kind of write it out is, well, 3 of these c's will cancel out with 3 of the ones on top, which reduce it from 4 to 1. We can, but that right there is as far as we need to go. There's a lot of steps. Questions on this here? Well, we're going to have to stop here.